Creating word problems from equations. Now, let's discuss about the inverse of what we explained earlier in this tutorial, i.e. learning how to translate equations into wordy problems. This is helpful as you learn how to connect math and real-life situations. For example, if we have the first-order equation with one variable, we have the following as shown on screen. It is possible to create many wordy problems using its components. Here we present a few of them. 1. Two friends have an equal amount of money shared between them. If they spend $15 to buy a book, they have $7 more left. What was the original amount of money each friend had? 2. Two school buses were transporting students. If 15 students drop off at the first bus station and after this, only 7 students are still left in the buses, how many students did each school bus initially have? 3. A soccer team scored the same amount of goals in the first 2 rounds of the league and conceded 15 goals in total. If the goal difference at the end of the 2 rounds is +7, calculate the number of goals scored by this team in each round. In this way, we can create as many such problems as we want using the clues given in the equation. Example: which of the following scenarios are suitable for the equation? We have the following shown on screen. A. 25 cakes are divided equally among 8 children in a kindergarten. If at the end only 1 chocolate is left, how many chocolates did each child receive? B. 25 tailors can sew 8 T-shirts each in a day. If there is 1 shirt left to sew, how many days did this process take to the tailors? C. If 25 days ago I had 8 cakes in my refrigerator and yesterday there were no more cakes left, how many cakes did I eat in a day? D. If 8 days ago I had 25 cakes in my refrigerator and now there is only 1 cake left, how many cakes did I eat in a day? Solution. The first thing to do with these word problems is to identify the variable. In the first example, the variable is the number of chocolates each child receives. We express this variable as x. Since there are 8 children in the kindergarten, they receive in total 8x chocolates. Thus, since initially there were 25 chocolates, and the number of chocolates left is 1, we can write the corresponding equation as 25 minus 8x equals 1, because the initial number of chocolates, total number of chocolates distributed among children equals number of chocolates left. Therefore, the first scenario fits the given equation. We have missing information in this scenario, as we don't know what the initial plan was. We only know that 25 tailors can sew 8 T-shirts per person in a day, so we can write 25/8 is equal to 200 for the total number of T-shirts sewed in one day. In addition, we know there is only 1 T-shirt to sew. So if the initial plan was 201 T-shirts, this takes only 1 day for the tailors to sew them. If the initial plan was 401 T-shirts, this takes 2 days and so on. Therefore, the equation given here is not suitable to describe this situation. The variable here is the number of cakes eaten in a day, but our equation is not suitable to describe the third scenario. The correct equation would be 25 equals minus x equals 0, or 25 minus 7x equals 0. This situation can be described by using the given equation, as the variable x is the number of cakes eaten in a day. Thus, since the number of days is 8, I ate in total 8x cakes. Initially, I had 25 cakes and now I have only 1, so the equation used here is 25 minus 8x equals 1, which is the same as the original. That is all for lesson 9.2.6, and the end of tutorial 9.2. To continue this chapter please watch 9.3, Introduction to Identities. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.